Welcome to Spring Lib.
Hello. In the question, we have given a simple relationship to describe the changing drag force would be given by if D is equals to minus BV. So this is the drag force. Now, so I will give you two solutions for this. There will be two methods. So this is the first method which I am discussing over here. So this is from the sum of the forces. So mg minus bv is equals to m times a. Now this acceleration we can write it as dv by dt, and this m I have sent it to the other side, so it will be g by m, so that will be just g, and this b by mv. So this b by m, now it will be appearing all the time, so it will create a confusion. So I'm taking this b by m as k. So I'm calling this b by m some constant k, because b is a constant, m is also constant, so it's fair enough to write this as a constant k. So then this equation turns out to be g minus kv is equal to dv by dt. Now we are doing separation of variable method. So I am bringing this to the denominator, and the dt I am sending it over here. So this equation turns out to be this. Sorry, here it should be a minus sign. So this is minus. So this will be now I have to integrate this. So what I have done is I have taken this as some y. So g minus kv I have considered it to be y. So if I differentiate both the sides, now g is a constant, so differentiation will be 0. Now kv, differentiation of kv will be d k dv is equals to dy. So now this dy is k dv. So I will put this value of dy over here. So this will be k, and dy is as k is constant, so I have taken it out of the integration, nothing new. So dy, and this g minus kv I have considered it to be y, so it is over here, and integration of dt as it is. Now we know that dy by y, integration of this is natural log, so it is minus k ln of y is equals to t plus some constant c, where the c is the integration constant. So we have to determine by using the boundary condition. So now I have just plugged the value of y back over here, because now I have to use the boundary condition. So when boundary condition means what? At the initial condition, at initial stages, what will be there? So at t is equal to 0, suppose this ball is coming with an velocity v0. So at t is equal to 0, v will be equal to v0. So then if I plug this over here, so this quantity will be 0, and this quantity will be just replaced by v0. So my c will turn out to be minus k ln of g minus k v0. So this is what we get. Now if I substitute back the value of c over here, so this equation will turn out to be this. So minus k ln of g minus kv is equals to t, and this quantity c is over here. So now if I send it to the other side, so it will be like ln a minus b. So it will be basically, if I send it to the other side, so I will get actually ln g minus kv not divided by g minus kv. But what I have done is I have compensated over here with the minus sign over here. So I have subtracted, I have put the minus sign both the sides, so that I can reciprocate this logarithm. So I have this minus sign take care of that. So now we know that if I want to, I have taken the natural, so I want to get rid of this logarithm, so I have taken exponential on both the sides. So taking exponential, I get this equation. So just a bit of rearrangement, so I'm sending this denominator to the other side, so I get this g minus kv is equal to g minus kv naught into e raised to minus kt. So again I have rearranged, so I've sent this kv over here and brought this g minus kv naught over here, so I get this equation, and finally I divide both the sides by k. So I get this equation. Now this equation is very useful to us, so we can put any time So at t is equal to 0, at t is equal to 10, whatever it is, and we can find the solution from here. But now for us, t is equal to infinity is important, because after a long time it will reach the terminal velocity. So at t is equal to infinity, this e raised to minus kt will tend to 0. So this entire quantity will turn out to be 0. So we will approach to vt. So vt will be equal to g by k from here. Now we know that k is b by m. We have mentioned it above. So this vt will be mg by b. So that is what our answer is. Now method 2. Now I know one thing, that at terminal velocity acceleration is 0. Terminal velocity is a constant velocity, and at constant velocity the acceleration becomes 0. So I have this equation. So I have this equation, mg minus bv is equals to m times a, but acceleration is 0. In this case the acceleration is 0. So at vt acceleration is 0. So my equation will turn out to be mg minus bvt is equal to 0. So from here mg is equals to b vt it will be. So from here vt will be equal to mg by b. The same equation, the same answer we get. But the fact is we have to use, I would urge to go through this method, the integration, the substitution of variables, because this will be very useful for solving the different problems. Like if this is squared, like bv squared, so at that particular time we cannot use this terminal velocity concept. At that time we have to use something, this integration and all this. So I urge you to follow this method very neatly. So I hope you find the solution useful. Thank you.